This video is for Math 70. I'm going to go over the problems from the sample test number 1. Alright, so problem number 1, we've got 2 minus 5 times 3x minus 1 plus 8 times x minus 4. So we've got 3 pieces in this expression that need to be simplified. 1, 2, and 3. This one doesn't really need to be simplified, but these two do. So we don't want to combine anything between them until we simplify each one individually. So this 2 will stay the way that it is. Here we'll get minus 15x plus 5, and then plus 8x minus 32. And then we want to find our like terms and combine those together. So this will give us negative 7x, and then 2 and 5 make 7. 7 minus 32 should be negative 25. Okay. Let's see here. Problem 2 is similar. Here we've got 7 times 2x plus 3 minus 4 times 5x plus 1 plus 12. Okay, so same approach here. We're going to distribute these two. This one's going to wait until we get done with that, and then we're going to combine our like terms. So 14x plus 21 minus 20x minus 4. So we've got a 14x and a negative 20x, and that'll make negative 6x. Let's see, 21 minus 4 is 17, and 12 is positive 29. And notice these are not equations. There's no equal signs. We're not solving for anything. We're just simplifying the expressions using the distributive property and combining like terms. Okay, problem 3 is a little bit more complex here. We've got parentheses inside of brackets. Let's see, 10 plus 8 times 4 minus x minus 2 plus 9 times x minus 7. All right, well, I'll just work from left to right here. I mean, we can start inside here first. Like if we want to follow the order of operations, it always says to work inside your brackets or parentheses first thing. We can go ahead and do that. This will be 2 plus 9x minus 63. Okay, let's see, over here, 10 plus, 32 minus 8x. And now you've got a couple choices here. You can combine like terms inside the brackets and then distribute the negative. I'm just going to distribute the negative into the brackets and then get going on combining like terms. So this will be minus 2 minus 9x and then positive 63. And let's see, with our x's, minus 9x and minus 8x makes negative 17x. This will be 42 minus 2 is 40, plus 63 is 103. Okay, so that's that first section on simplifying. In the next group of problems here, we want to substitute in some values. Let's see, we've got x is negative 2.57, y is 6.22, and z is negative 0.83. And let's see, problem 4, we're going to have z minus x all squared over yz minus x, and then plus xy over here on the side. All right, we're going to need the calculator for this one. So let's plug in our values. Z is negative 0.83. This subtraction is part of the problem. Then we get a second negative sign that comes along with the value of x. And so it's going to look like that. On the bottom we'll have y times z, 6.22 times negative 0.83. And then again, this minus sign is part of the formula, but the value of x will have a second negative sign as well. And then plus x times y. Okay, so there's a lot going on in this problem. Let's see, where do we want to start? Well, they always say, like I said, the first place to start in the order of operations is inside the parentheses. So that's what we want to do. We want to combine this, and when the order of operations says work inside the parentheses, it means get whatever's inside there down to a single number. Okay, you don't want multiple numbers inside your parentheses, you want a single number. So this negative and negative make a positive, and so we'll have positive 2.57 minus 0.83. Let's see, I think that's going to be 1.74, but I'm going to double check that. 2.57 minus 0.83, 1.74, good. Positive 1.74, and that's still going to get squared. Down on the bottom, 6.22 times negative 0.83. Let's try again. 6.22 times negative 0.83. Negative 5.1626. And then we'll have a plus 2.57 down there. Over here, this plus and minus, that'll give us a negative 2.57 times 6.22. 15.9854. All right, so I'm going to square that 1.74, 3.0276, and on the bottom, negative 5.1626 plus 2.57, negative 2.5926, and then we still got this minus 15.9854 over here. So let's divide these. 3.0276 divided by negative 2.5926. Negative 1.1677, I'll call it 1678, and then minus 15.9854. 15.9854. And so we're going to come out of this with negative 17 point, I think we want the nearest hundredth, yeah, 15, negative 17.15. Okay. Let's see, the next problem, I think we've got the same values for x, y, and z, but a slightly different expression that we need to evaluate. So let's see here. Problem 5. We start with x squared plus 5z minus zx plus y over z squared. Okay, so first I'm just going to plug those values into the variables. So this will be negative 2.57 squared, 5 times negative 0.83, and then minus negative 0.83 times negative 2.57 plus 6.22 over negative 0.83 squared. Okay, so now we've got everything plugged in, and we want to start evaluating these things. And again, these separate pieces can be evaluated separately. So let's see here. First, I'll square this negative 2.57. And if you're going to square this on the calculator, be sure to put parentheses around that, otherwise it'll give you a wrong answer. So, negative 2.57 squared. And whenever you square a negative number, you should be getting a positive result. 6049. And then 5 times negative 0.83 minus 4.15. And then let's see, up here, negative 0.83 times negative 2.57, 2.1331 plus 6.22. And then again, when you square a negative, you should get a positive answer, 0.6889. Okay, well there we go. Let's see. Let's simplify this fraction. And when I say simplify, I mean just calculate it. I don't mean cancel out the common factors. So let's see. This will be 8.3531. And let me double check that. Yep. So 8.3531 over 0.6889. So let's go ahead and divide. 12. So this will be minus 12 point, I'll call it 1253. Okay, so we're just about done here. 6.6049 minus 4.15 minus 12.1253. And so to the nearest hundredth, this will be negative 9.67. Okay. Well, that's the first page of the test. And we've got those two sections, one on simplifying by combining like terms, and this last section that we were talking about was about substituting values into an algebraic expression. The next group of problems are going to be equations, and we're going to want to solve those for x. Well, let's take a look at a couple of these. So 6, we've got 5 plus 3 times 2x minus 4 equals 9 times x plus 1 minus 7. Okay, so I'm going to simplify each side and then collect all the variables on one side, all the constant terms on the other side, and then isolate the variable. So this 5 will stay the way that it is. Here we'll get 6x minus 12. Then on the other side, 9x plus 9 minus 7. So this will be, let's see, 6x minus 7 and 9x plus 2. So I'll subtract 6x on both sides. And then subtract 2 on both sides. So we get 3x is negative 9, and x is negative 3. Nice whole number. We're not always going to get whole numbers as our answers, but in this case we did. Okay, problem 7. Let's see, 5/12 x plus 2/3 equals 7x minus 3/4. So this is just an equation like all the other equations that we work with. The fact that there are fractions in here shouldn't prevent you from solving the problem. Now, you're going to need to be able to calculate with fractions. How you do that is up to you. I frequently do it by hand. If you've got yourself a good scientific calculator, then there should be a fraction button on there. These graphing calculators don't really handle the fractions really that well, but they're actually pretty good. Instead of using the fraction key, you would use the divided by key, because that's what the fraction bar means. It means divided by. All right, so in any event, let's see. We're going to subtract 5/12 x on both sides. So we'll be left with 2/3 there. Let's see. 7 minus 5/12 is going to give us 6 7/12, which I guess I'll turn that into an improper fraction, which is 79 over 12. And then minus 3/4. And then we're going to add the 3/4 to the other side. And then we get 79 over 12x, 2/3 plus 3/4. Again, how you add these together is up to you, but you need to figure out a way to do it correctly, okay? You can make a common denominator here. This would be 8/12, and then this would be 9/12, and so we would end up with 17/12 on the other side. And then you can divide on both sides by 79 over 12. I'm in the habit of multiplying on both sides by the reciprocal. The 12s cancel out. We end up with 17 over 79 as the value for x. If you did this and ended up with a decimal, you'd end up, with about 0.215, which is a pretty good approximation. Okay, there's problem 7. Problem 8, we've got some decimals in here. These are a little bit easier to work with. Negative 0.60 times 15 minus 0.35 times x plus 2 equals 0.85x. Okay, let's see here. Negative 0.6 times 15, that should be 9. Negative 9. Negative 9 minus 0.35x minus 0.70 equals 0.85x. Okay, let's see here. I'll add this 0.35x to both sides. And what's left over here will be negative 9.7. This one, let's see, if we add these up, this should be 1.2x. And so then we just divide on both sides by 1.2. Let's see, so negative 9.7 divided by 1.2. X is going to be negative 8.083 repeating. Okay. All right, so there's that next section. Those were those 3 linear equations that we needed to solve. One with whole numbers, one with fractions, one with decimals. All right, let's look at the next problem here. So what's next? Problem 9. So these are what they call literal equations, where you're solving for one variable in terms of other variables. So in this one we've got u plus 7 over m equals 6 plus k. And what do we want to solve for? We want to solve for the u. Okay. So here's the u right here. To isolate that, we're going to have to undo all the things that are happening to it. Okay? One of the things that's happening is it's getting divided by m. Another thing that's happening is it's getting 7 added to it. So to undo those things, we're going to have to undo dividing by m, we're going to have to multiply on both sides by m. So that'll cancel this out, leave us with u plus 7. And the parentheses here are important because that m gets multiplied by both the 6 and the k. And then the last thing we need to do is subtract 7 on both sides. So u is 6 plus k times m minus 7. And we can leave it like that. You can distribute the m inside the parentheses if you want to, but you don't really have to. All right, let's see here. Problem 10. We've got P equals A plus n minus 1 times D. And here we want to solve for the n, which is inside the parentheses. So the first thing we want to do is get this thing by itself. So we'll subtract a on both sides. P minus a on one side, n minus 1 times d on the other side. Let's see here. We've got a variety of choices at this point. So one thing we can do at this point is to divide on both sides by d. So that'll cancel this out and leave us with n minus 1 equals p minus a over d. And then we can just add 1. And that would be one answer. Another thing you can do at this point is you can say p minus a is nd minus d, and then you can add d to both sides, and then divide on both sides by d. And so p minus a plus d over d is another correct answer. These, this, and this are the same thing. I mean, if you look at it, if you separate off the p minus a over d, what's left is d over d, which is 1. So this is correct, this is correct. It doesn't matter which way you do it. Okay. All right, one more problem on here. Let's see what we've got. Problem 11. We want to solve for y. So k equals m plus ay. And we want to solve for this y right here. So again, similar to what we did in this one, problem 10, where we subtracted the a away from this side before we worked with this expression, that's the same thing we're going to do here. We're going to subtract the m first so that we can then work to isolate the y. So we get k minus m equals ay, and then we can divide on both sides by a. Whoops. I guess I should stick with the green here. Y equals k minus m divided by a. And there we go. Okay, so remember that you need to come to class to take your test. If you have any questions or need any help, please let me know. And best of luck.